Good morning. Today we are going to see space forces. So in last three videos, we are with the problems of forces in plane. Today we will go forces in space. So now to see more videos on this topic, that is engineering mechanics or subject, you have to go to Civil Engineers Technical Hub. You have playlist over there. In this playlist, you have to go to engineering mechanics, and then you will see all the videos are related with engineering mechanics. Now space forces. So in plane, we have two types, we can say, considering your axis. So we have plane forces. And in plane forces, we are with two axes. So it may be XY axis, it may be YZ axis, it may be XZ axis. Generally, in plane, we are using these two axes, X and Y axis. Now, when we will switch over to space, means we have three axes. And you can see over here, we have X, Y, and Z axis. So we have to find, when we have plane forces, we have to find component that is along x-axis along y-axis. Means if I will say this will be angle theta, then we have x component as f cos theta. Here we have three axes and we have to find three component along x, along y, and along z. So now let us, we will consider a force. We will consider these three forces, F1, F2, F3, and these we are in the axis X, Y, Z. Now, to find component of this force, we have F1 bar is equal to Fxi plus, you can write cap, Fyj plus x1 I will mention plus fz1k. Means any, now we are considering, we are talking about F1 only. So F1 bar is Fx1i, that means component of force along F, along Y, and along Z direction. Now we have magnitude of this force. We have this as F1. And F1 bar, this will be vector, and F1 we have scalar. Now, F1 we will get equal to root of. Now you can see, if I will consider here, that is F equal to, we have under root of Fx square plus Fy square. In same fashion, here I will get Fx1 square plus Fy1 square plus Fz1 square. And from this we will get Fx1, Fy1, and Fz1 as component of F1. Now, Fx1 we will get Fx1 equal to mod of, or I can write it as F cos theta x, where theta x is the cosine angle. That is angle made by force F1 with x-axis. And from this we will get cos theta h, and that is equal to mod of Fx1 upon F. Similarly, we have theta y with the angle made with a y-axis, and we have Fy1 upon f, and theta z will be the angle with z-axis, and we have this will be Fz1 upon f. Now, if we will put a value of fx1 as fx cos theta, fy1 as f cos theta y, and fz1 as f cos theta z in this equation, that is of f. And from this I will get f1 that is equal to root of, now fx1 is f cos theta x, so square of this. F1 now we have to mention over here because we are considering f1. So we have f1 square cos square theta x plus f1 square cos theta y plus f1 square cos square theta z. And from this we can get f1 common, and we will have f1 is equal to f1, or we will take square on both sides, and we have f1 square in bracket cos square theta x plus cos square theta y plus cos square theta z. Now this f1 square gets cancelled, and we have square of cosines that is equal to 1. So plus cos square theta z, and that is equal to 1. So square of cosines that is equal to 1. We should know this also, and therefore this equation that is derived over here. So cos square theta x plus cos square theta y plus cos square theta z, and that is equal to 1. So this is first part. Now then we have how to write a force, that is most important. Let we have a force of magnitude f, and this is acting. Now arrow we are showing, that is it is going from A to B. Magnitude we have, that is f. Then how we will write f bar? So we have f bar equal to f into b bar minus a bar divided by mod of AB. And then we can have this equal to f in bracket. Now f b bar, so we have x2, y2, z2 and x1, y1, z1. So we will get it as x2 minus x1i. So we will write below, will be better. So f in bracket f x2 minus x1i plus y2 minus y1j plus z2 minus z1k divided by AB we have root of x2 minus x1 whole square plus y2 minus y1 whole square plus z2 minus z1 whole square. And from this, we are in position to calculate value of f. So this x2, if I will consider this as L, then we can write this value as L, and we can have this as f bar equal to f in bracket x2 minus x1i upon L plus f into y2 minus y1 upon L, sorry, j upon L plus f in bracket z2 minus z1 k upon L. And this I can write it as f bar is equal to fxi plus fyj plus fzk. So component along x, along y, and along z direction. So we can find component of the forces in this fashion. Now, what are equilibrium equations in this? So now we have here three axes and we have equilibrium of concurrent only. We are not going to study general force system in this. So we have concurrent force system. Now if you remember in plane, and in plane we have concurrent force system. We have only two equilibrium equations, fx equal to 0 and fy equal to 0. Now we have equilibrium, but this equilibrium is in space and we have three axes. So we are going to get three equations, fx equal to 0, fy equal to 0, and fz equal to 0. So likewise, we are going to get these forces. In plane, we have a resultant equal to Rx equal to root fx1 square Rx, that is, sorry, Rx we have, that is summation fx. Rx equal to summation fx. Ry is equal to summation fy. And R is equal to root of Rx square plus Ry square. Now here we have three axes. So this we are talking when we have resultant. Now when we have resultant, then in this case, we will have Rx same equal to Fx, Ry equal to summation Fy, and Rz equal to summation Fz. And resultant we will get equal to root of Fx square, or I will say Rx square plus Ry square plus Rz square. So we have same, only in plane we have two axes and in space we have three axes. Now we have problems that is on parallel forces. Now general for parallel forces, and here we are interested to find a resultant only. A resultant we have to find magnitude also, and we have to position magnitude and position, but this position we have to find with respect to origin. So with respect to origin means we can say this O. Now we have to find first a resultant, and we know we have no force in x direction, so Rx 0. We do not have any force in z direction, Rz 0, and therefore we will get Ry equal to summation Fy, and that is equal to minus F1 minus F2 minus F3 and minus F4. And this will be here as Rx and Rz 0. So R is equal to Ry. And that is addition of these forces. Now to find X position of the resultant, or x coordinate we have to find. Then for x coordinate, we have to take, now you can see, so we have this will be F2. Now, if you will see the coordinate of the forces, we are in this fashion. Now, of all these forces, your y component, sorry, z component is 0. Why z component is 0? Because my forces are in xy plane, which is passing through origin. And therefore, we have all these z, these are 0. Now, forces or coordinate of f, it is on x-axis. So I will get value of y20. Means from where I have to measure this x coordinate, I have to measure from y-axis. And therefore, to find x coordinate, we have to take moment about y-axis. Moment about y-axis. And here, we are going to consider Varignon's theorem. What is Varignon's theorem? So Varignon's theorem, that is moment of all forces about y-axis equal to moment of resultant about y-axis. Now from this I will get, let we have resultant is acting somewhere here, and we have coordinate of this x, y, and z. Now we know we have z0, so we have x and y. So x, we have distance from y-axis, so we have this distance. Now distance of f3 we have, so this distance is x3. Then x4, so we have this distance as x4. Parallel to x-axis gives me x coordinate. Parallel to y-axis will give me y coordinate. So distance of f1 is x1, f2 is x2. Then what I will get? f1 x1 plus f2 x2 plus f3 x3 plus f4 x4, and that is equal to r into x. And from this I will get x equal to summation fx divided by r. And similar way, I can find y also, which is summation fy upon r. And knowing this, we are going to get position of this resultant, and this resultant is of f1, f2, f3, and f4. So likewise, we have two types of problems in examination. One we have on equilibrium and another is on resultant. So now we will stop here only. If you are not a subscribed channel, then subscribe Civil Engineers Technical Hub, and to see more videos, you have to go to playlist Engineering Mechanics. Now we will stop here only. So thank you.